Hey, this is Evan Wright, and he's going to be talking about Text Adventures Revisited. Thanks,
Okay,
Evan.
thank you. Hi, everybody. Normally, there's not this many bright people when I give talks. Actually, there's bright people. There's just fewer of them. So it's cool to see so many people here. So I'm going to talk about this thing that I've been working on for a bit, but I'm not going to talk specifically about the project until the very end. And if you want to see it or you want the code, I'll be happy to give it to you. It's more about how text adventures work in general as opposed to my specific project, although I'm definitely going to talk about that. So just a little blurb about me. There's a bad Photoshop of me in a cave with a lamp. I'm really, I love text adventures. I watch Get Lamp like Rain Man's got to watch Wapner. I'm also a teacher. These are some nice buildings where I teach. During the day, I teach at a vocational high school, and I teach game design. And then in the evenings, I teach C# at a community college. So game design, if you're not familiar, that's what we have to call computer science now to get people to enroll. Right? Sad, but it's true. And I haven't always been a teacher. Before I was a teacher, I was a programmer until I decided that it made me miserable. And they called me Eeyore. That was my nickname. They were, okay, I'll go fix that bug. Right. So now I'm much happier now. So that's what I do. I get to do I bring a lot of retro gaming into the class, and I think text adventures have a real place in game design classes. And maybe I'll talk about that later. Obviously it's the 40th anniversary, and I thought, well, okay, what kind of cool retro project could I come up with for the 40th anniversary of the 1977 Trinity here that would kind of maybe glue them all together? And I thought, okay, well, I love text adventures, and text adventures are easy to port, so maybe I could design some sort of system that would run on a modern computer, like a PC, and then it would export your game to whatever target platform from 1977 you wanted. Now, there was a hiccup in this plan. It turns out I don't actually own a Commodore PET. I don't really want to own a Commodore PET. My wife definitely doesn't want me to own a Commodore PET. But up in Chicago, where I live, there's a very active Cocoa community. And Cocoa 2s are plentiful and cheap. And it turns out there's a really cool processor in there, the 6809. I think it's like the one I think it's very similar in its instruction set to the one that's in the 2GS. So it's a really cool processor. In fact, it's probably my favorite out of the bunch in terms of just ease of use. It's like they read my mind. This is kind of what I ended up with, this tool that would export to these three platforms. And I've actually since thrown in Sinclair Spectrum, but I didn't have room on the slide for that. So it actually exports the 4 platforms right now. So if you want to do text adventures, there's some really good starting resources out there. Like, where do you start? There's a language called Inform 7, which which compiles down to these virtual machine that was used in the early Infocomm games. So that's if you want to know like what capabilities should a text adventure have or a text adventure tool have, that's a very good resource to use. The Z machine, which is Infocomm's virtual machine, has been reverse engineered, and the spec is out there. Unfortunately, the spec doesn't tell you how the parser works, because the parser isn't part of the Z machine. It was actually built into the game itself. So I had to do a little digging to kind of figure out, experimentation, trial and error, try to get it working. And then also, this is a book I love. It's available for free on the internet. It's Creating Adventure Games by Tim Hartnell. Somebody has lovingly PDF'd the whole thing and put it online, and it's great because it explains an adventure game in very simple terms in BASIC, and there's lots of pictures that show you how a simple text adventure game written in BASIC would do. And this is what I did on the Apple II, by the way, when it was the mid '80s. We had an entire lab full of Apple IIes, and I loved it at the time, but now looking back on it, I feel even more lucky because I've realized that most people didn't have that experience. So that was my intro to the Apples, was when I was in middle school. So it turns out text adventure is basically just 3 things. You need a parser to get the user input and chop it up and try to figure out what the user's trying to tell you. You need lots of data tables, so that what you're trying to do is map that input to the data for your game. You're trying to convert words to numbers, right? And the tables are the way to do that. And then you need subroutines. So if I say, if the verb is kick and the noun is can, then call the kick can subroutine, right? So that if you can put those 3 things together, you can have a text adventure. But The thing that really makes a text adventure kind of stand out or fall flat on its face is the quality of the parser. So I mean, and that's why the Infocomm games were so great. It was really the parser kind of allowed you to talk or to type to the computer in the language that you were thinking in your head, versus some of the clunkier ones where you have to kind of do this translation process of learning how to talk to the game. And to me, that kind of breaks the immersion a little bit. I want to enter commands to the game the way I hear them in my head. I don't normally hear things in my head, by the way. So this is going to be mostly about the parser and how to get that to work. And then what else does the game have in it? Well, it's got rooms and objects, and it turns out that those are the same thing. Right? There's no, as far as the game is concerned, there's absolutely no difference between a room and an object. It's just an entry in a table that has properties and attributes. So an object knows what its ID number is. It knows what the ID number of its description, how it's initially described to the player. It knows, it has like north, south, east, west attributes, so it knows how it relates to the other objects in space. It maybe has a weight. And it has flags on it that say, like, is this thing portable? Is it a container? Is it a supporter? Like, can I put things in it? Can I put things on it? Is it open? Is it closed? Is it emitting light? Right, and those are just bit flags. Those are just ones and zeros, right? So there's a little bit of space wasted, right? Because a room could be emitting light, but a room probably isn't locked. I mean, a door could be locked, but a room couldn't be locked. So there's sort of, it's not a perfect match, but it works, right? And if your table entries are a fixed size, it makes crawling through your tables really, really easy. And you spend a lot of time crawling through tables. Okay, so these are the bit flags I was talking about. Like, objects have little ones and zeros on them that say, is this thing a container? Is it lockable? Is it open? Is it emitting light? So like a lamp can emit light, but a room can emit light too, right? So there's a commonality between objects and rooms aren't really as different as you might or objects and rooms are not as different as you might think they are. And here's that in kind of a visual form. Like, here's a map I was working on with my son. We were making a Doctor Who text adventure game. He's 11 years old. He actually really likes text adventures. And you can see here, if you go west from the street, you end up in the cave, because I didn't really finish making the map. And if you go east from the cave, you end up back in the street, right? There isn't really a cave in the middle of London. Hey, it's Doctor Who. You can do whatever you want. So that's, objects have relationships to each other spatially. And then here's another kind of picture about how objects relate to each other in terms of containment, right? So in these Infocomm games, or in the system I've come up with, there's a conceptual object called Offscreen or Offstage, and that's the parent, that's the root of your object tree. So all the rooms generally have Offscreen as their parent, and then the cave could contain the rocks and the player. The player is the parent object for the bag and the lamp, right? So the player is carrying the bag and the lamp, and then the bag contains gold and bottle or something like that. So there's kind of this weird graph tree structure going on here. But again, that is all very, very easily represented as a table, where every room or every object has an entry in the table, and you've got your attributes and your bit flags that say, like, whether this thing, that describe how you can interact with that object. Okay. I keep talking about tables. You need lots and lots of tables. But unfortunately, thank God, tables are actually pretty easy to process. Actually, with the 6502, I was totally scratching my head, like, how does this work with only 8-bit registers? Until I found that, like, indexed, 0-page Y indexed address modes. I'm like, yes, it can be done. These are examples of the tables you need. You need tables of articles, and that's for, like, removing white space from the input. You need prepositions, because the prepositions are the flags that you use to kind of chop up your sentence. Or it's, if it's on the right side of a preposition, it's probably the indirect object. If it's on the left side, it's the direct object. The prepositions are kind of the delimiters in your sentences, or it's how you tokenize things. You need a dictionary that just has a list of all the words that the game understands. So if the player types, like, greet the Smurf, right? Like, I don't understand the word Smurf, right? Because it's not in the dictionary, right? You get the word, you crawl through your dictionary. That's your gatekeeper. That's your bouncer. It's like, sorry, you're not on the guest list, right? I don't know the word Smurf. You need a dictionary. You also need a list of verbs, and notice, like, the verb table is a little bit different, right? It has an ID number on every verb, and that's so you can have synonyms. Like, so get, take, and pick up are all ID number 0. So the user could type in any of that stuff, and it would all map to verb number 0, right? And that's a way of creating synonyms and creating, like, a more intelligent, or a parser that kind of catches more input and funnels it toward the correct action, as opposed to, like, having to play hunt the verb. that was how, that's how you can do synonyms for verbs, or nouns too, right? Okay, so you also need this other weird table. I'm not the best PowerPoint slide designer, I apologize. So the purpose of this table is to map the words in the dictionary to that object table. It's the glue that ties those two things together. So let's say the player has typed in the word get rusty. You're like, okay, rusty is the direct object. Can I map the word rusty to a particular object? So rusty here in this table is word 0, and then word 0 maps to object number 5, right? So rusty iron lamp, right? That would be words 0, 2, and 3 in the dictionary, right? So you've got some mapping of the words in the dictionary to the objects in the game, and that way, and that's how like the Infocomm works. Like you could type, you don't have to type like kill troll with sword. You could say kill troll with elvish, right? Because it's an elvish sword. It recognizes any one word in that it recognizes those words as belonging to or being associated with that particular object. You need another type of table. You need jump tables. So you're going to have your subroutines that carry out the special actions in your game, like kill troll with sword or whatever. Give something to Floyd. So you need this, and this is the point of having like ID numbers associated with all of the possible input words. So it's like if the verb is kill and the direct object is troll and the preposition is with, then call all that kill. Then call this subroutine. And these aren't words; they're actually numbers, right? Tried to put the number sign in here. I missed the one on verb. But so this would be if the verb is 5 and the noun is 3 and the preposition is 2 and the indirect object is 7, then call that subroutine, right? So you're trying to take this possibly broad input and funnel it down to a specific case that you can then execute. And then if you can't find a case to execute, then try a default action, and if you if you still don't have a default action for that, then just say I don't understand what you're talking about. Yes.
I just had a question. I
Yeah.
might be jumping ahead.
No.
The
Go ahead.
sideways,
Yeah.
I'm not sure, but when you're writing the logic to string together the verb, direct object, number, preposition, and so forth, to then get to the subroutine represented by each of the different combinations.
Yeah.
Have you engineered that into essentially like an indirect jump to get to the subroutine?
Yeah, that's exactly what it is.
Okay.
Yeah. And that was weird going to implement it because I don't think the 6502 has indirect jump. It's like you have to fake it somehow. Or maybe I'm wrong about that, but you guys might know better than I. All the assembly languages have kind of blurred together in my head at this point. And now when I go in to type assembly code, it's like I start typing Z80 instructions into 6502 files, and it ends up being. It does?
I think so.
Even the
Okay.
straight 6502 does.
Okay,
Yeah,
maybe it does.
Yeah, you have to go off
Yeah,
as
if you jump in.
Okay. But that's exactly what it is. It's an indirect jump, and somehow I got it to work. It doesn't have an indirect a call, right? So you can jump, but you have to set it up like a function call. So you push a return address onto the stack and then jump.
right, yeah.
So the subroutine you're jumping to can return as if it were a subroutine.
Right, there's no like indirect JSR essentially.
Yeah, so the 6809 actually does have that. I'm like, oh, that's so cool, right? And then I went to Z80 and they didn't have it, and 6502 doesn't have it. So, so you have to mock it up using. You have to do what the call instruction would do for you anyway.
Yeah.
But this is generally what you do is you build a big jump table and then try to map what the user typed in to a subroutine and then call that subroutine. If you can find a specific one, that's great. Call that. If you can't, try to find a generic subroutine, like for the verb get or something. You're going to have a built-in get function. If you can't find that, like if the verb is something that's not in the dictionary, something that's not in the verb table, then print like I don't know the verb, whatever. So you're trying to build like a generic catch-all case and then try to find specific stuff. Yes, sorry.
Have you ever talked to linguists to see what they think of their structures and how that corresponds to their...
No, I'm really sure my middle school English teacher would be like really psyched that I'm using the word predicate. Like, it's like I know what that is now. I'm using that for something. Right. But that brings up the question of like what about writing text adventures in another language that doesn't maybe has a different kind of imperative structure. Yeah. No, I mean, like, so the next bit is going to be how it actually, like, breaks up the sentence into words and, like, the weird rules that English has, or the simple rules that it has sometimes. Okay, so there's our jump table. Okay, you also need string tables. So, like, the description of an object is, like, string number 3, right? So, and then string number 3 is, you know, a large trunk of jewels, or the large trunk of jewels is battered and rusty, or something like that, right? So you've got you don't hard code text and things. You're printing out string ID numbers. The description for this is string 5. Print message 12, right? So you need some sort of big string table you can crawl through. Okay, so here's like the heart of the talk is how the parsing works. So the first thing you want to do is like clean up the input, remove like the articles that people might be tempted to type in. Try to figure out what's the verb. Is there a direct object? Is there an indirect object? And then try to map those, make sure that those words are actually in the dictionary, and if they're not, just say, I don't know that word. And actually, it's kind of cool. If you go play Zork, you realize that's how it works, because you could type, like, get, back to the Smurf, get Smurf, right? Or get squid, or something, make up some word. It says, I don't know that word. But if you type, like, get scarab, it says, you don't see that. So you can actually, if you're smart about it, you can use that, the way the parser is structured, to tease out the vocabulary in the game. You're like, oh, there's a wrench somewhere in this game, because it recognized that word. But that's cheating, so don't do that. That's like taking stuff from the free pile and selling it on eBay, right? And then once you've got those parts of speech isolated, try to map them to words in your dictionary, or map those to words in your dictionary, map those to objects in your object table, and then crawl through your sentence jump table and see if you can actually find an action that maps to that. So here's. So here's an example, right? So pick up, basically, I just decided everything was going to be uppercase. Right? So I have a TRS-80 thrown in here somewhere, and it doesn't have lowercase. So I'm like, okay, everybody gets uppercase. So if they type in that for some reason, maybe it's the version that does have uppercase, convert it to uppercase, and then remove the, right? You go through that sentence, you try to remove all the articles out of it, right? That's what the article table is for. So you've cleaned up your input. You said pick up iron sword. You've uppercased it and removed the white space. And then in English, the rules of imperative English sentences. The first thing is always going to be the verb. The first word is always going to be part of the verb, so pick. Now, we have compound verbs too, like pick up, turn on. And if you wanted to get really fancy, you could say, hey, turn the light on, right? So there's this preposition dangling way at the end of your, I use the word dangling preposition. Happy English teacher. You could have a preposition all the way at the end of your sentence that actually applies to the verb, which is the first one, right? So if you wanted to get really fancy, you could say, if the last word is a preposition, that's actually the second word of the verb. But I didn't go that far. So pick up, like here, the second word's a preposition, so that's actually a compound verb, right? So the first two words are actually the verb. So then you try to look that up on the verb table and say, oh, I don't know that. Or I do know that. Okay, and if you do know it, then keep going, right? So the next thing is, like, can you find a preposition here that would be breaking, like pick up the iron sword with the pliers or the tongs or something, right? If you can find a preposition here, then you've got an indirect object stuck on the end. That's not the case here. So the rest of this thing, the predicate, has got to be the direct object of the sentence. So so both of those words should be applying to the same object. And Infocomm, and I'll get to this in a second, how they do their disambiguation, they would look at all of those words. I just cheaped out, I kind of cheeseballed it, and just looked at the first word. So like in my thing, it would just look at the word iron and try to say, can I map iron to a noun? And that costs you, you save complexity, but it costs you when you have to disambiguate things, right? You can't disambiguate. So there's no preposition in here, right? So that whole thing's got to be the noun. And then, why is my slide not going to the next? Okay. I try to look up iron. Okay, there we go. I've talked ahead of my slides. There we go. So iron is in the dictionary. Look it up in that object table. Figure out what object it maps to. Okay. And then go crawl through your sentence table. Here's like the more complicated version of that. Remove the Fromitz board with the shiny pliers, right? Something from Planet Fall, right? Okay. So here's the same thing. Like the first word is the verb. Let's say it's verb number 10. Then you've got your direct object. I'm ignoring the second word. Like Infocomm would actually look at that. And then there's a preposition here, so that means that there's an indirect object. So I'm going to look at the first word of that thing and say, okay, well that is associated with object number 12, right? So now I've mapped that whole sentence down to 10, 3, 4, and 12, right? And then I look at my sentence table, I crawl through there, and I say, can I find a routine to jump to that would handle that? Right, so that's kind of how you map your user input to your functions. How am I doing on time? Anybody? No? Okay, well, I'll keep talking then. All right. Okay, and then the disambiguation thing. I was like, how does it disambiguate? You know, do you mean the rusty key or the shiny key, or the nasty knife or the rusty knife or something? How does it disambiguate? Okay, and that goes back to like the whole thing where it's gonna like the inform parser Infocomm will look at every word in that sentence. So what it does is it says, it gives every object a score. I think I've got a slide for this, right? So it looks at, there's 3 words that apply to this object, and it's going to look at each word and say, okay, well, if it applies to an object, I'm going to add 1 to the score. And then like this other word, like shiny or whatever, it applies to that object too, so I'm going to add 1 to its score. And what you're doing is you're trying to build up a score for every object that indicates whether, you know, how well it matches what the user typed in. So that's pretty clever, I thought. And then if you get a tie, then you go through your object table and you print out, you know, all of the possible matches. Like, which do you mean and then you print out everything that had that tied score. And then there's a couple of things like, if the object isn't visible, like set its score to 0, right? So like, if you know, in a game you might have 10 desks or 10 locks or 10 doors or something. So you don't want to just match the first one you find in the table. You want to match the one that the player sees, the one that's in his room, right? So discard things that you don't see, and then also and then sorry, I got these backwards. And then like if there's a word that doesn't apply to an object at all, just then set the word score to 0. So if you have like the orange elvish sword, like orange doesn't map to elvish sword, right? It doesn't map to it doesn't map to elvish and sword. So that object is it's unmappable at that point, and you just say, sorry, I'm not going to consider that object. Okay, so what I've done is I've made a GUI. This is in C#. It's on Windows, and what it does is it allows you to create a game, and then set all those properties and attributes on your object. It allows you to add verbs. It allows you to add those sentences. It allows you to write little routines in there. And then it's got a menu up at the top left somewhere. Oh, this is an old slide. You don't see it. I'll give you a real demo, though. You could say, okay, export to Apple II, export to TRS-80, export to Cocoa, export to Sinclair Spectrum. And then what it'll do is it'll actually write out assembly language, and then you can assemble it. And then you have a running game for that target platform. So the IDE, it just basically stores your game as in a big XML file. And then when you go to export it, it reads the XML file and then writes it out to whatever platform you want. And then you have to run an assembler on it. And that creates the output file and attaches it to a disk image. So you can go straight from your PC to a target platform without having to really write too much code. The thing's got its own little built-in language for the from doing the custom stuff about that makes your particular game mechanics. However, it turns out that remember those objects, they just have attributes and properties. All you're really doing in a text adventure is if something, if a crate explodes and becomes a pile of wood, you've just moved the crate object off screen and moved the pile of wood object on screen. It's very easy to create that user experience just by changing those properties on objects. And in fact, that's all it is. But it's like, it's like there's only like 12 notes on a keyboard, right? But we have an infinite amount of music, or four letters of DNA. But somehow using that, we come up with all the life on Earth. Right? So it turns out just with that little simple tool set, you can make some really cool stuff. Okay, so why don't I just give you guys a demo, and then I don't want to run into the next guy's talk. Or I got 5 minutes. Okay, perfect. All right, great. Thank you. And there is no next guy's talk. Okay, so let me quit out of here. Oh, wait, there we go. No, what happened to my video here? It just conked out on me. How can I connect back to the projector? PC's duplicate. Come back, projector. There we go. Okay, so yay. Oh my God, my presentation's ruined. All right. Oh, by the way, this is really cool. This is a picture of me from 1983 in Timex Sinclair User Magazine. That's the kid with the army jacket. Oh, thank you. that's me in the army jacket and with the kid with all the hair, and I have to stress the hair when I show this picture. Right? Yeah, I know it was a long time ago. Okay, so here is the tool. Let me just start it up in the debugger, and this is all available online. It's up on GitHub, and I'll track me down, or I'll put up the slide. But if you miss it, just track me down. I'll give you all the code. I'm the worst salesman ever. I'm like, here, have it for free. So I'm going to create a new project here, and I'll just call it KFest Demo. Whoops. KFest Demo. Why can't I type? This is really bad if you're doing text adventures. All right, I'm just going to call it KFest _ KFest. There we go. Okay, short welcome message. KFest Adventure. It's hard to type with so many people watching. Okay, and I'll put in for my author name, Evan Wright. There we go. And then I'm just going to save it here. I'll say save as. I'll call it KFest. So it saved it as an XML file. And then what I can do is I can go to my next tab over, and here's where I can add in all the objects and the rooms. And it gives you Offscreen. That's the parent of your hierarchy. It gives you that by default. It gives you a player object. The player is no different from any other room or object. And it gives you a default room to start in. So let's go to, I'm going to go to the room 2 here, the first room, which is object 2. And it says this is the end of a dirt road. I'll say you are in a large conference hall. In Corcoran Hall. There you go. And I can say whether by default I've got the emitting light thing checked. And I could go in here and I could add other rooms. I don't think I really have time, but you could add other rooms and other objects in here and hook them all up. I could create objects and put them in this room. And then let me just do the export and see if it works. I can add, here's a tab, I can add my own verbs. I can put rules on verbs. Like if you want to wear something, you have to be holding it. If you want to open something, you have to be able to see it, something like that. And then it's got its own little language here that's kind of like C, and all it does is there's no looping, there's no function calls. It's just comparing, if this attribute is true, change these other attributes on these other objects. And it turns out that's all you need in a text adventure. Here's where you create the mapping. Like if the verb is this and the direct object is this, call some subroutine. And then you can make subroutines that get called every turn, like the thief randomly pops up in Zork or something, or if you don't have light for 3 turns, you get eaten by a Gru. You can put in stuff like that. You can add your own variables. There's some built-in ones too, like a score and health and all that. Okay, so just to export this thing, I should be able to. Now there's a lot of people here, so that increases the likelihood that this will fail. It's like an inverse relationship. So now I just go up to the export menu and I say export to Apple II, export complete. That tells me go open this directory. So now I'm going to open up Cygwin here, and I'm going to type ls, and there should be, okay, there's a folder here called KFest _ Apple II. So let's go in there, KFest _ Apple II. And if I do an ls in there, you can see there's all these assembly language files, right? So that tool actually wrote out the assembly language for that game. There's a common shell for the Apple II games, and then what it does is it takes the data you put in, and it writes out the tables, and then it copies them all into the same directory. And I should just be able to type build.sh. Okay, there it is. So I just assembled it, attached it to a disk image, and popped up the emulator. And I even had it copy a file into my ADT Pro directory. So now I can make copies of it. So now if I type catalog, so game.bin, brun game.bin. Oh, it didn't work. Okay, it almost. Oh, KFest Adventure. I just don't think it saved the. I didn't save it after I changed the name of the room. But there it is. KFest Adventure, Evan Wright version 1, room 1. This is the end of a dirt road. So it just didn't catch that room description. So, why am I clapping for myself? Thank you. I just wanted to be part of the group, right? So. And that works for TRS-80, it works for Radio Shack Color Computer, and it works for Sinclair Spectrum. There's still some glitches with it. It's not really quite ready for prime time. But if you want a copy, I'll be more than happy to give it to you. It's up in my GitHub account right now in the badly misnamed directory front end. So it's github.com/EvanCWright. And if you go there, you'll see the Wright project. Like the description says what it is. I can't give out like the tools that I don't have the license to distribute. Like I don't have a license for the, I don't have permission to distribute the assemblers that, that do the final assembly, and I can't really package up Apple Commander and stuff like that. So you'd be on your own to get that stuff, but I'm sure you have it already since you're here.
But do you have any documentation saying what we would need to get if we wanted to create our own build environment here?
No. Would you like some? Because I got a couple more days here, right? So no. Okay. Yeah. No. It's a work in progress. I'm trying to get it to the point where actually my students could use it. And so back to my point, like at the very beginning of the class about game design, I get students that walk in like, I want to make an MMO. I'm like, whoa. Like, back up. So slow it down. So a text adventure is the one kind of thing where I could see you could come up with this amazing design for a game and then actually go do it, because you don't have to be an artist, you don't have to be a 3D modeler. With limited programming skills, you could actually do it if you had the right tool. So yes.
Is this running under Visual Studio, the thing that you just did, that created that? Not what created the disk image, but where you had all your.
That guy?
No, the thing
Oh.
before that.
Yeah, I'm running it in the debugger right now, but.
But what is that actually? The thing that you showed us, where you put the names on it and said this is the end of a dirt road, and you had.
Oh, that's the output of this project, right? So, so I would upload the.
So what
Actually,
do
the.
I need to run this if I want to do that myself?
Oh, it's up on GitHub. It's in the bin debug directory.
It's a Windows executable.
It's a Windows executable. Thank you.
Oh,
Yeah.
Distributing executable as well, or just the source?
It's all up there. The source is up there too.
Okay, both.
Yeah.
Okay, cool.
Yeah. I'm that kind of guy. Yes.
Might it ever be a design goal to have it be able to C# to have it run on mono, or is that not possible?
It's in the back of my head to do that. I think actually, because I teach C# at night, I think doing the parser would be a great programming exercise for students, because you'd have to use all the .NET data structures. So that's like on my long-term goal, because you should be able to test your game without having to actually run it in an emulator. You should have some sort of little test environment to speed up your development cycles. So it's in the back of my brain. Yeah.
I mean, yes, you need to run under Unix.
Yeah, if it could run on Mac OS or Unix or Linux, basically, yeah.
Yeah. I don't mean it.
Using mono project.
So but the interface is all done in Visual Studio, or it's using the .NET libraries, and I don't know how much of that mono.
Yeah,
I don't think mono
Well,
encompasses
I'll
that.
test it out. I'll take the executable and see how it runs.
Oh, okay, yeah, no, we can do that. Yeah.
Mono has pretty good .NET support now.
Oh, great, fantastic. Okay.
There's also a .NET 4 2.0 came out today.
Today?
Go check that out. I don't know what the
Okay. So yeah, I mean, ultimately, I'd like to throw in Commodore 64 as well, and Windows. Yeah. So it turns out, like, once you get it on one architecture, to get it to the Commodore, I just have to change the input and output routines, and I'd have to change the zero-page variables it's using, and that would be it. It would probably take me like a weekend. Yeah.
So does it have Atari 8-bit support?
Not yet.
Good.
No. I'll put it in just for you. Okay. So we're out of time. Okay, thanks. Oh, I'm in room 201, or you'll see me wandering around. So if you want this thing, I've got a demo game too. So I've got like 10 copies. If you want a free demo game I made using this, I'll give it out to you. It's like in baggy 1980s style. If you want it, just ask me. I'll be happy to just give the whole thing to you, and you can have fun with it. Okay. Thank you. Thank you.